let's look at a few more examples. A study published in the Journal of Personality and Social Psychology asked a group of 200 randomly sampled men and women to evaluate how they felt about various subjects, such as camping, healthcare, architecture, taxidermy, crossword puzzles, and Japan, in order to measure their dispositional attitude toward mostly independent stimuli. Then, they presented the participants with information about a new product, a microwave oven. This microwave oven does not exist, but the participants did not know this and were given 3 positive and 3 negative fake reviews. People who reacted positively to the subjects on the dispositional attitude measurement also tended to react positively to the microwave oven, and those who reacted negatively also tended to react negatively to it. Researchers concluded that some people tend to like things whereas others tend to dislike things. A more thorough understanding of this tendency will lead to a more thorough understanding of psychology of attitude. So what is or are the response variable in this study? The response variable is they're measuring their attitude toward some sort of fictional microwave oven. So what is the explanatory variable? So the explanatory variable, it may have been hard to pull out. It was rather a long problem, but it's that dispositional attitude they talk about. Does this study employ random sampling? Yes, it says that they did. So we take them at their word. Is this an observational study or an experiment? And let's explain our reasoning here. So this was an observational study since there was no random assignment to treatments. So can we establish a causal link between the explanatory and response variables? No, this is an observational study, so we can't do that. Can we generalize to the population at large? Yes, we can. The results of the study can be generalized to the population at large since the sample is random. So make sure you don't get confused here. We have a random sample, but we did not randomly assign to treatments. Initial sample was indeed random. We have 200 randomly sampled men and women. So our sample was random, but we did not assign treatments randomly. We didn't have treatment 1, treatment 2. So a quick note on generalizing. So earlier we discussed sampling versus census, and often we take a relatively small sample, apply some treatment, and then look at the results, comparing them to other possible samples. So in general, we are wanting to make an inference to some population. We have to be very careful when we generalize to the population. So generalizability relies on random sampling. If we want to learn about a population, we need to start with a random sample from that population. Additionally, if we want to compare 2 different types of treatments, we have to rely on randomization. So this is that idea that of randomly assignment to subjects to different treatments. Example 8. In order to assess the effectiveness of taking large doses of vitamin C and reducing the duration of the common cold, researchers recruited 400 healthy volunteers from staff and students at the university. A quarter of the patients were assigned a placebo. The rest were evenly divided between 1 gram of vitamin C, 3 grams of vitamin C, or 3 grams of vitamin C plus additives to be taken at the onset of a cold for the following 2 days. All tablets had identical appearance and packaging. The nurses who handled the prescribed pills to the patients knew which patients received which treatment, but the researchers assessing the patients when they were sick did not. So no significant differences were observed in any measures of cold duration or severity between the 4 medication groups, and the placebo group had the shortest duration of symptoms. So was this an experiment or an observational study, and why? So look back. Was the treatment randomly assigned to each patient? Yes, so it was an experiment. So what were the explanatory and response variables in the study? So the response was that duration of the cold. They were measuring how long the cold lasted. Explanatory, we had treatment, and then we had 4 different levels, right? We had the placebo, then 1 gram, 3 grams, and 3 grams with an additive of vitamin C. Were the patients blinded to the treatment? Yes, they were blinded. Was it double blind? Well, kind of, right? It was sort of partly double-blinded. The nurses knew what was happening, but the researchers themselves did not. So we'll call it partly double-blinded. And then the last part here, participants are ultimately able to choose whether or not to use the pills prescribed to them. We might expect that not all of them will actually adhere to this and take their pills. Does this introduce a confounding variable to the study? No, it does not. The patients, while they were randomly assigned to treatment groups, They were blinded, so we would expect about an equal number of patients in each group to not adhere to the treatment. Example 9. Chia pets, those terracotta figurines that sprout fuzzy green hair, made the Chia Pet a household name, but chia has gained an entirely new reputation as a diet supplement. In one 2009 study, a team of researchers recruited 38 men and divided them randomly into 2 groups, treatment or control. They also recruited 38 women, and they randomly placed half of these participants in the treatment group and the other half into the control group. One group was given 25 grams of chia seeds twice a day, and the other group was given a placebo. The subjects volunteered to be a part of the study. After 12 weeks, the scientists found no significant difference between the groups in appetite or weight loss. What type of study is this? This was an experiment, right? There was a treatment imposed on by the researchers, and the people were randomly assigned to that treatment. So what are the experimental and control treatments in this study? The treatment was the 25 grams of chia seeds twice a day, and the control group was just a placebo. Did they use any blocking in this study? And so if so, what was that blocking variable? They did, right? Blocked on gender. Has blinding been used in the study? Yes, but it appeared to only be single blind. Comment on whether or not we can make any causal statements and indicate whether or not we can generalize the conclusion to the population at large. Well, since it is an experiment, we can do a causal statement. However, they found no significant difference, so we can't say that one caused weight loss because there was no difference found between the 2 groups. Since the sample itself was not random, the causal statement that could have been generated could not be generalized to the population at large. It is very important that we take a simple random sample for our initial study in order to generalize to the population.